So what we're going to talk about today is how to inherit code from different code bases. And this happens to us throughout our careers, pretty much like, actually, too often probably, where we join new companies or we're just consulting for some other people, and you just have to go in there and look at their code bases and say, like, make something out of it, right? And you're being hired to adopt those code bases and try to change the code in there, improve it, add new functionalities, et cetera, et cetera, et cetera. So whether you're changing jobs or you're just consulting for some other people or you're contributing on a community, this is likely going to happen to you. So yeah, that's me. I work at Elastic now, and if you're wondering why I left Red Hat, I can buy you a coffee later. There's nothing bad about it, but it was my time. So happy to talk about it later. And let's get straight into our content. So inheriting stuff from someone that actually hated you. And I was trying to figure out a good way to kind of like present this topic, you know, like there are different ways to do it. Like there are different kind of projects out there. If you open a new code base and you look at a project, the project might be perfect in the sense that it has tests, it has documentation, it is written following all the best practices that there could be, and life would be perfect and amazing in that case. But talking to friends, we were kind of like discussing and going through what I wanted to present, and one of the ideas is that it would be more useful, I guess, if we could start from or talk about the worst case scenario. So that's what we're going to focus a little bit on today. And the arrows don't work anymore. Okay, there it is. And the sad story. So the sad story is when you join a company or you're consulting for someone else and you find a project that has basically no documentation. It has no test whatsoever. The code is written poorly. Like, whatever you can find in the code base is just horrible and hard to read. Like even the indentation is all off. Like if you're reading Python, it has 4 and 2 indentation. Like it's a fucking mess. And then you have the use cases that are unclear as well. So it's not only the code base horrible, but also the use cases are not clear at all. So the program, the software seems to be doing way too many things and not really what it is supposed to be doing. But what it is supposed to be doing is also not clear because no one actually took care of writing down what the software should be doing. And on top of all that, you also have deadlines. So you've been hired, you've been contracted for this, and whomever hired you told you, you know, this is the code that we have. It's been touched by at least 10 million people, and you are the latest one that is going to touch it, but we have deadlines and we need everything that you're going to do to be ready in a month from now. So what do you do in those cases? So what I would like to do is kind of like walk you through what I would do, a list on what it's become kind of like a process for me, and just kind of walk you through it and work through it together. So the first thing I normally do is like I want to understand the what, then I understand the how, and then I understand the why. And we're going to go through this a little bit. But one thing that I try to keep in mind when working on this first step, on this first phase of adopting code that is not mine, is that I try to do it with the least amount of biases possible, right? I try not to form any kind of opinions while I'm going through this. And this is what I normally try to answer. So you have the what, the why, and the how. So the what is the first thing I try to do. So what are the use cases? You know, what is this software for? What are they trying to achieve? Why? You know, what is the adoption that it has? You know, whether you have a big use case or a big user base, and whether there are many customers that are consuming the software or whether there are not that many. So this is very important, in the sense that if you have a big user base, it means that whatever changes you are doing to the software are going to have a huge impact if something goes wrong, right? Which doesn't mean it makes it more important that use cases or that or makes it more important than software that doesn't have that many users. Not having many users doesn't mean that you can just break the software and pretend that it never happened. It's just the impact is lower if you have fewer people using it. The other thing I try to do is, what's the planned work? What's the deadline? What are the goals? Where do we want to get with this software? What other things do we want to add to it? And of all those things that that had been done already or that had been planned already, I also like to understand which ones we've done already, right? So in the software that I'm adopting, there's some implementations for some of these things that we want to do, and there are some others that are likely going to be missing. So which of these are missing, and when are they scheduled for? So the second thing is understanding the how, and there's really not too much to say about it, other than I like to understand how were things done. So this is when we start looking into the architecture. We start looking into how the software has been written. If it is a distributed software, I try to understand the architecture, how it's been deployed, and what tools were used to deploy it. When we talk about the software specifically, I try to understand what kind of coding patterns were followed, what kind of best practices were followed, and everything. As I try to get as much detail as possible just to understand what it is that I'm getting myself into and what it is that I'm actually adopting. And again, there's not a lot to say here, except that it is important to start looking at the how without many biases, because one thing that we developers do is that, or believe, is that every developer believes that they're a better coder than any other developer in the world, which in many cases is true, but to actually compare yourself to other developers out there and try to, air quote, criticize or judge the software that you're reading, you also have to put yourself in the same situation that the person that wrote it was, right? So you don't do benchmarks and get two different computers from the software in those two different computers under different contexts and pretend that the benchmark is going to give you the right results. So if you want to compare the code and you want to understand why someone wrote the code the way they wrote it, you got to put yourself in the same situation, under the same pressure, with the same deadlines and the same time, I guess. A good example of this could be, you have this Python script that is just shelling out, right? You have this Python script that has to talk to a service, and the way the person that wrote the script decided to talk to the server, to this service, was to just shell out, create, basically call the CLI, call the shell, and call the CLI tool and talk to the API of the service. And then you read this code and you say, right, but there's a Python library for this. So why are we calling commands on the shell when there's a Python library that we could be using, right? And that is totally true. I would do the same. I would probably ask myself the same questions, and that would be one of the first things I would propose changing, right? But one of the things that could happen is that when that script was written, the Python library didn't exist, right? And the only thing that had available was the binary and the shells, and that was the only way to do it. So this is just a very simple and kind of stupid example, I guess, to explain why you have to put yourself in the same context and at the same time with the other developer. So the other thing that I try to do is understand why things were written the same way. And again, this goes back to, I get the script, I see a bunch of shell commands, and I want to understand why those shell commands existed. I see when the script was written and try to understand how I can improve it. You want to understand if there are tests that are missing, why those tests are missing. It could be that the developer just don't know how to write tests, or the person just doesn't like tests. It could be a culture problem. It could be that the company doesn't believe, or the person, the owner of this code, doesn't believe that tests are important. So those things are they sound scary and weird, but those are cases. Those people exist, and those are things that you have to keep in mind just to understand what you're getting yourself into. And the same thing applies for documentation. If the documentation is missing, it's the same thing. It could be practice problem. They don't have, like, there's no process to write the documentation. There's no, not necessarily like automated process. There's not even like the culture of doing it. Whenever you propose a patch, like, no one asks you to write the documentation, or it could be also like a company culture that needs to be changed. But it gives you enough information to understand what has to be changed in the future whenever you start doing it. And this is like kind of like just a quote to complete the first step. And so, like, the big difference, or not really the big difference, but one like very important difference between a mature developer and I guess the rest of the developers out there is that a mature developer, before judging the code, it just like seeks for the why and tries to understand why things were written the way they were written before just judging the code they're reading. And it could be like, some people just have bad taste, right? Not everyone is a saint, or no one is a saint, I guess. So some code is bad because people don't know how to write code, but some other code is bad because, you know, it was the best they could do at that point. So the second thing, or the second step in this process, would be to familiarize yourself with the environment, the user base, and evaluate a possible rewrite. So we're adopting some code. We tend to just assume that the only thing we can do with the code is refactor it and keep adding stuff to it. But rewriting the software is also an option, which has to be consciously evaluated, but we'll get there. So I'm not going to spoil anything, actually. So, and to kind of like understand and familiarize yourself with the code base. So the first thing I'd like to do is learn how users are consuming the software, right? So the software it was written for people to use it. And I want to understand if there are users of this software. I want to understand how they're using the software, because it gives me a clear understanding of what is the alignment between the people that were behind this software and the actual consumers. Like, many times, even like in big companies, you have product managers that give you all the use cases and how, you know, what the software should be doing, but then you realize that your users are using it in a completely different way, because it turns out that the use case that you created the software for is not necessarily theirs, but they found a new way to use it and for, you know, solve a different problem. So I like to understand how people are using the software. Many times this information is not really available. If you work for a big company, probably the information is available. They have all the information about how their customers are using the software. But when you are contributing to an open source project, many times gathering this information is really hard. So I wouldn't get like completely hung up on this, but if you have a way to ask your user base how they're using the software and get like a sense of how you should be using it, it is super great, and it gives you a lot of information. So the second thing would be run the software, use it. Leave changes for later. Like, don't be tempted. It's really tempting when you open like a new code base and you see things that you don't like and all the best practices are not being followed. It's really tempting to just like start changing things. It's like, oh my God, why this guy did this? And like, you just like changing all the things like global variables. Oh no. And then you delete all the files and you create new ones. So like, hold on for that. Like, start by running the software, and running the software will give you even more information than what your user base will give you. So you have all the data that you gather from your user base. You know how your customers are using the software. Now you try to run it. You try to run it how it should be run, air quote, how it should be run. And you then try to run it how your customers are running it. And you just run it. And if it is a library, you just write a script that uses the library. Just use the API, call all the functions that are exposed and that are supposed to be used by your customers. And try to do it with all the default values, for instance. We like to think that good software is written with saint defaults, which means that when you download it, you can just run it and it will have default values for all the configuration options that are good for the average use case. Most software out there doesn't do this. So keep in mind all those things. Try to run it without any CLI parameters if it is a CLI tool. Try to call the functions with the default values if it is a library. Try to set different values. Try to use different CLI options, et cetera, et cetera, et cetera, until you get all the information. It'll probably crash, and it is fine if it crashes. Get all the information that you can. Get all the data and move on. read the documentation, read the code and everything there is. This is the moment when you start reading in more detail all the code that has been given to you. You have run the software, you know why it is failing. You can start debugging all those failures and start familiarizing yourself with the code base specifically and not so much with the entire ecosystem. But you also have to evaluate a rewrite. So 99.9% of the time, it is not needed. And I totally made up that number because I don't have the actual number. But it is a way to tell you that most of the time, you don't need to rewrite the software that has been given to you. There are, however, good reasons to rewrite software. One of them would be analyzing understanding whether you are familiar with the language and the ecosystem. If someone gives you some Ruby code, you'll be like, oh my God. But then there's also a good rule in engineering is that if something works, just don't touch it because you're probably going to break it. So if you end up rewriting this software, you might just be breaking your entire user base, right? All your customers' environments. So the fact that it is written in Ruby doesn't necessarily mean that you have to rewrite it entirely. But it is definitely a good indicator that since you're going to be maintaining the software, is definitely a good indicator that you might want to rewrite it. And this is not to pick on Ruby, honestly. It could be any other language that you're not familiar with. Another question to ask is that would a rewrite make it faster? Would a rewrite be faster than refactoring the entire code base or refactoring the things that I have to refactor? Would a rewrite make it easier to maintain the software? Like if the code base is a complete shit show and you're like, this is impossible to maintain, this is impossible to even refactor, would a rewrite make it better? In the long run specifically, you gotta think, you can't think just about the task that you're supposed to be doing now. You have to think in the long run what it's gonna be better, what's gonna make your life simpler. Another thing would be will other members of the team be able to contribute if I rewrite the software? So if most of the people in the team are Ruby developers and you're the only Python one and you end up rewriting the whole thing in Python, then you might be the only one that is going to be able to touch that code base, which is not necessarily the best thing. So the third thing would be building your guarantees first and then refactor or implement. What did I do? Okay, yeah. So if there are no guidelines, write them. This is how you start building and writing your guarantees. Write the guidelines. It sounds very simple and stupid again, but if there are no guidelines on what the code base should look like, how things should be written, how things should be defined and documented, write those guidelines because that's going to be your proof basically. That's going to be your way to say, this is how we're going to be doing things now, and this is the guidelines that we should be following. Without these guidelines, this is what happens. And you can point people to the code base that you're going to work on. Document everything, usability, APIs, environment, everything. And know that so far we haven't coded anything. We haven't refactored anything. We haven't implemented anything. We are basically building the guarantees around the software that we're going to be adopting so that whenever we start modifying it, we are protected by all these guarantees. And all these guarantees will not only protect us, it will also protect our customers, which are the ones that we don't want to break. So document everything that you can. If it is a distributed environment, document the architecture if there is no documentation for the architecture. Document the API if there is no documentation for the API. Try to document all the CLI parameters. It will teach you a lot about the software that you're adopting, and it will also stay there for posterity, basically, and it will make your life simpler in the future. And all the existing tests, of course, they must pass. And if they don't exist, you have to write them. Because those tests, the ones that exist, if they exist, they are your source of truth. And if they don't exist, you have to write them. And in that case, your source of truth is the code base. So you read the code base, you can make some assumptions about what it's supposed to be doing and how it is supposed to be working, and you start writing your tests. And those are going to be the guarantees that whenever you modify something, you're going to be preserving the exact same behavior. And right now we're talking about refactoring code. It doesn't matter whether you are going to change a function and the test will have to be rewritten later. What you want first is be able to refactor everything and without breaking the test, without breaking the customer base. Once you have those tests, you can start modifying things and then refactor the test, okay? It sounds like a lot of work, and it sounds like more work that you probably are willing to do, but it is the kind of work that is gonna, again, guarantee that you're not breaking customers, that you're not breaking users, and that you're also, keeping your community happy, I guess. You have to have a source of truth. Again, if the test exists, that's your source of truth. If they don't exist, you start reading the code, and you can make some assumptions based on the APIs that have been exposed to the public. The fourth step would be break down your strategy, do small and focused changes. And I'm not going to go into the details of how you code and how you should be writing Python or how you should be refactoring the specific function, but rather I'm going to give you some, highlight some ideas on things that I keep in mind when I'm doing this. So the first one is one small change at a time. Don't try to do 3 changes. Don't try to do, plan 5 months of work ahead. Find specific parts of the software that you believe should be improved and start improving them, start refactoring them. So refactor is just taking existing software and making it better. It's not making it better based on your taste, it's making it better based on what the best practices out there are. And those best practices are pretty much documented everywhere in the internet, so you can find them. So one small change at a time. Break down your work in a way that you can do a single change. And the reason you want to do small changes is because those are isolated from the rest. If you do a big change, then you might be breaking 3 different things and you're never going to understand why, because you're new to this code base. So find one small thing that you can do, even though it doesn't look like you're doing a big work or being extremely productive. Find several small changes and start doing those. That's going to teach you a lot about the code base and the project that you're going to start working on. Focus on progress and not perfection, which means you want to make progress on the work that you're doing. You don't want to refactor the code until it is perfect before you merge APR. What you want to do is start making, again, going back to the point before, the previous point, you want to do small changes in a way that will allow you to make some progress. So perfection is not needed. Perfection is never reached. What you need to do is find a compromise between the time that you have available, the current status of the code base, and your current knowledge and the best that you can do right now. So do the small changes, focus on be able to make progress, land all those small changes, and then you can start increasing the size of your changes and the kind of work that you're doing. So don't change the functionality during that refactor. This doesn't mean that this is not an all or nothing. You can start refactoring code while you're implementing new features and new functionalities. But when it is the other way around, when the changes that you're doing are only meant to refactor the code, try to never change the functionality, because that almost always ends up in breaking something, right? You're not trying to implement something new. You're trying to make the existing code better. So you don't want to change the behavior of the software. What you want to do is improve the quality of the software. So the 5th step would be to run. Run far and fast. Far away so that no one can ever find you in case you broke everything. I'm just kidding. So the 5th step would be repeat 3 and 4, basically. And at that point, well, just congratulations, you have a new baby. And you can start taking care of the new software that you have in your hands. And you gotta keep doing 3 and 4 over and over again until you feel the owner of the software. And it's not that you have to own it, but you gotta feel like you own it. You gotta feel like you know pretty much everything about it, so that whenever you have to do more refactors of this code base, you are not gonna be scared of doing them, basically. So as a final point, don't try to take the shortest path. Aim always for the fastest one, even though it might end up being the longest one. So I read something interesting. This is a good analogy, actually. And I'm sorry I don't remember the author, actually. But so the analogy went something like, if you want to go from city A to city B, there are probably many paths that you can take. But two of them are, Going through the town, going through the city center from city A to city B, which is the shortest path, but it might be the slowest one because there's a lot of traffic, there's people, et cetera, and everything, all those things that happen in a city. But the second option could be just drive somewhere else for 10 minutes, hit the highway, and then hit the gas until you get to the second city, which is the longest one because you end up doing more route, but you end up going faster because you are on the highway, and then you can just hit the gas. So taking this back to software, it might sound like the shortest path to implement something is just open the file, change the function, and just like go with it and put it in production. Whereas the longest one is doing everything I just said, take extra time, which is not, I understand that it's not always possible, but like the second option would be like do everything that I just said or similar processes and do more work that you're probably willing to do and start implementing all those things. And this might make the first two steps or the first two iterations lower, but in the long run, it's just going to make your life simpler, and it's going to make refactoring future code way faster because you already have everything documented, you already have tests that you can use, you already have code that you can rely on. So some highlights: understand the what, the why, and the how. Build your guarantees before changing the software. Focus on progress, not perfection. Know who the consumers are. This is extremely important. Don't pretend that you're the only one using the software because that's just going to make you create bad APIs and not provide a good service. And document everything: API, architecture, environment, everything that you can document. And that's pretty much it. Thank you very much. And I was told there are some questions, I think.
Definitely. So you mentioned writing guidelines if they are missing. Do you have a way of motivating people to actually read them and contribute?
Yes, don't merge the patches. If someone doesn't follow the guidelines, just don't merge the code. Point people to the guidelines and say, like, this is the guidelines that we're following, and this is the way we do things here. And I understand that if you're new to the company or new to the code base, you might not have the power to do that, but that is the kind of change that you want to do. That's why you try to understand the environment and the culture of the company, because that's where you need to start. If you don't start changing the culture, then things like the software that you're adopting are going to continue happening.
Right. Often legacy code bases have no tests and lots of complexity that has accumulated over the years. How do you approach that when the code is hard to test?
Well, that's a good question, especially because legacy code bases always strike back. And so one thing you want to do, I guess, follow the same process until the point that you realize that the legacy code base is just not maintainable anymore. And if it is not maintainable, again, you got to do a good and honest check on whether rewriting the code base is the right solution. And I understand, again, that it is not always possible. But if the code is too hard to test because the legacy, the code base is very old, you might want to start refactoring the code in a way that it is testable. And once you refactor in a way that it can be tested, then you start writing all the test suite, I guess. But again, you have to have a way to prove that you have not broken any of the functionality that there is in the code base. So either it is test or like a good acceptance environment that you can use, et cetera, et cetera, et cetera. But you have to have a source of truth just to make sure that you're not breaking your customers.
Thank you. What if your deadlines don't allow for time to refactor?
You're going to keep accumulating tech debt, I guess. And adopting a new project is like inheriting money from someone. Like, they give you a lot of money, but then you have to pay taxes on it. And it's pretty much the same thing. The technical debt of the project is now yours, and you have to carry it. So if you don't take the time to do it, and again, I realize that not all the companies are going to give you all the time you want to refactor the code. But in that case, if you have to implement new functionalities, whenever you're implementing a new functionality, this goes back to the exception that I was saying. Like, I would never change the functionality if I'm refactoring the code, but if I'm implementing something new or changing the functionality because that is required, I will try to refactor the code.
And one last quick question. Do you prefer doing improvements as part of regular work, leaving the code in better state and then you find it, or separating it in new pull requests?
Again, it really depends. If I'm changing the functionality and I'm implementing something new, I'll probably just refactor it right there. You can split it in different commits. If you're working on GitHub, like you can have multiple commits. If you're not working on GitHub, I would still do it in different commits. Like if you're using Gerrit, it'll end up being different reviews, but I'll still separate them in different commits. But you can still do it as part of the same task. That's what I meant.
Okay, thank you. Unfortunately, that's all the time we have. So if you have more questions, find Flavio around. Thank you, Flavio.
You're very welcome.